Okay, hello again. So the three methods of vector addition are, the first two are graphical. So we need to do some graphing here. The first method is the polygon or tip to tail method. And the second one is parallelogram method. And then the third one, component or analytical, you need to solve it. This is the third one, analytical method. And I will make a separate video for the component or analytical method of vector addition. Let's start with the polygon method. So in polygon method, you are going to draw the vectors in such a way that they connect the lines. So let's have one vector. Let's say you have, let's say this is your vector A. Oops, okay, it's straight line. And let's say this is your vector B. Okay? And now, what I did is I connect the tail of vector B to the tip of vector A. So it's like tip to tail. That's why it's called tip to tail, because you're going to connect the vectors. And the resultant is, you're going to draw the resultant from the origin to the tip of the last vector. So you're going to draw it from the origin. So here is our origin here, the 0 mark. Okay, so what you're going to do is draw this line. Okay, so this is now your resultant. Again, our resultant is usually R, which is equal to A plus B. So take note here, the quantity, the direction is being considered. So what, in our example earlier, we have negative vector. So what if you have negative vector B? Okay, so let's say you have this vector. Oops, my hands are moving. So my hands are moving. Apologies for the non-straight line. Okay, so how about vector B? So my vector B is, it's the negative vector B. It's in opposite in direction. So this is my vector B. So I just connect the tail of vector B to the tip of vector A. So the resultant from the origin to the tip of the last vector. So as you can see, the resultants are different if you consider, if even if they have the same magnitude, B has same magnitude, it's the same length, but negative B is opposite in direction, so the resultant is different. Okay, so this is your resultant. So let's have a practical or a thought example here. What if you're riding on a boat with a, what do you call this? It's like a flag. Okay, so this is a sailboat. Now I remember. So what if you have a sailboat and you are moving in this direction, following the flow of the current of this is the current of your river, for example. Let's call it vector A. But there's some wind blowing, and the direction of the wind is somewhere on the side. That is your vector. Let's call it vector B. So you cannot just go straight, right? Because there's some other force, the force of the wind. So it pushes the sail to some other direction. So you're going to add them differently, but we are going to use parallelogram method for this. Okay, so I'll just write it on the next page. So we have this direction. For polygon method, what you're going to do is connect the dots. Okay, so you can draw vector A. You can start with vector A first. So let me erase that one. So let's say vector A. So it's moving in an eastward direction. Okay, and then you have vector B moving in a downward direction. You're going to connect that like this. Okay, so what is now the resultant? So this is your vector B, this is your vector A. So the resultant now is connect the dots from the origin to the tip of the last vector. So this is your resultant. So you're going to expect that the sailboat will not move forward, but because of the wind, it might move a little bit backward, as you can see here. So yeah, our sailboat is somewhere like this. Ching. So somewhere, originally it's from here, right? But it will be pushed backward by the wind. So that's the effect of the vector here. You have to compute it with its direction being considered. Let's see another example. So let's have three vectors now. So let's say this is your Cartesian coordinate system, like that. And let's say you have vector A to the east. Okay, I'll use a different color. Let's say you have vector A to the east, like this. Okay, and let's say you have vector B somewhere like this, north of west. Okay, and let's say you have another vector, let's say vector C, like that. Toink. It's getting complicated now. So this is your vector C. Okay, I can write an arrow above. This is your vector B, and this is your vector A. Okay, so in Polygon, you just have to connect the lines. So the resultant is connect from the origin to the last tip, to the last arrowhead. So this is what I'm going to do. I'm going to connect from A to the last tip, and that is the tip of vector C. So this is now your resultant vector. This is your vector R. And that is, the vector R is A plus B plus C. So that's your resultant. So for polygon, you just have to connect the dots. And then how do you determine the angle? So you can determine the angle by using a protractor. So if you're going to use a protractor here, okay, you can get the angle theta. Okay, and somehow this is north of west, because this is north, this is west, this is south, this is east. Of course, you have the arrow here. Okay, how about your vector C? Vector C is downward and then to the west, so it's south of west. So in a way, your vector C is south of west. Your vector B is going to the north and to the west part, so it's north of west. While your vector E is just horizontal going to the east, so it's east. Okay, so let's now discuss the second method of vector addition, and that is the parallelogram method. Okay, let's go to the next board. Okay, so for method number 2, parallelogram method, what you're going to do is basically going to draw a parallelogram. So I'll show you with an example. So let's say you have vector A. Oops. Let me use a white color. Let's say you have vector A. Okay, this is your vector A. And let's say you have your vector B. So wait, let me, so this is our coordinates, something like that. So this is your vector A, and let's say you have another vector, vector B. In parallelogram method, you are going to draw the second vector and all other vectors from the origin. So this is our origin, the 0. Okay, so let's say vector B is to the, let's say, somewhere south of west. So let's say this is your vector B. Okay, now how are we going to determine the resultant? The resultant is, again, you're going to draw a parallelogram. Is a line parallel to vector B and parallel to vector A. No, that's the first step. The second step is now draw a diagonal line from 0 to the diagonal. So this is now your resultant. Okay, so I'll show you another example. So this is your resultant, which is A plus vector B. Okay, so let's have another example. Let's say, let's draw a coordinate. Oops, like this. So this is our 0 here. So let's say vector A like this. That's your vector A. And let's say you have another vector B. Again, from the origin. And let's say you have another vector C. So it's a little bit more complicated now. So this is your vector C. This is your vector B. Okay, so there are 3 vectors here. What you're going to do is draw a line parallel to A, B, and later on, you're going to add the C. But first, A and B. Draw a line parallel to B, okay, and draw a line parallel to A. So you just made a parallelogram. And then the initial resultant of A plus B is from the origin to the tip or to the diagonal, A and B. So this is your A plus B. Now, how are you going to add vector C? This is what you're going to do. Draw a parallel line to vector C from the other side, something like that. And then draw another parallel line, not with A or B, but with A plus B. A plus B, draw a parallel line. Okay, so it's something like that. And then the resultant, finally, of A plus B plus C is that diagonal. Okay, so this is now, oops. Oh, why is it like a line? Okay, never mind. I'll just draw it. Doesn't allow me to draw a straight line. So this is now your resultant, and that is your A plus B plus C. So this is something critical. You need to add AB first and then A plus B plus, and then plus C later on. Okay, so very different. Parallelogram, you draw the original points at the 0 mark or 0 position. While in tip to tail, you're going to add all the lines from the tip, and then here, from here, the next from here, next from here, and so on. But in parallelogram, all the lines start at 0. Okay, and then to determine the direction, then you just need the protractor and measure this angle, and it should be uh, north of west. So the answer should be C is in north of west. So something like that. Okay? Okay, so I will give you some tip. I found a software that is available online from fetcolorado.edu. It is very useful for you guys to do some graphical analysis or graphical addition, the two methods basically. So here I have here, let's say vector A, and you have another vector B. So I'm doing now polygon method. So let's say something like that. And then I have another vector, let's say vector, there's color is the same. Let's say vector C, something like that. Okay, so what's the resultant? Um, for polygon, you connect from origin to the tip. I hope I can change the, no, you cannot change the angle. Okay, we cannot change the angle. Perhaps let me try again, if this is possible here. Oh yeah, this one, you can change the angle actually. So let's say vector A, but the color is the same. You have another vector B. Oh, you can change the angle. Something like that. Or let's say, let's put some angle. And you have vector C. But why is it? Okay, the angle is opposite. So let's say this is your vector C. Okay, the sum or the resultant is from the origin to the tip. Oh, it will already give you the answer. So this is something nice. Look, uh, the angle is, what's the angle? I think it's 53 point something. I cannot see it. And then, so you should write, what is the magnitude? So the magnitude of, we don't know, but it's actually given here. But this one is, for the S, the X component is 7, the Y component is 12. So to determine the magnitude, you have to measure the length of this. There's the resultant, okay, and that's the magnitude. And the direction is about 59.7 north of east. This is polygon method. How about for parallelogram? So let's say if I move this, and then for parallelogram, you're going to connect everything at its origin. Okay? But here, you're going to draw a parallel line. I hope there's an option. No. Oh, no, it was erased. So there's no option to draw a parallel line. So we cannot also write. Okay, so let me annotate. So if you're going to draw a parallel line, parallel to B, oops, it's not straight line. Okay, let me delete that, erase. Okay, let me draw a straight line. Should be parallel to B. Oops. And parallel to A. Is it parallel? Perhaps. And then the resultant of A and B is this. Okay? Now to add vector C, you need to draw another parallel line, but this time parallel to C. And then parallel to AB. And finally, the resultant is the diagonal line. Let's just change the color. Look, did you notice something? Should be something like that. Did you notice something? Whether you are going to use a polygon method earlier, this is the resultant of polygon method, the parallelogram method should also get the same answer. So note, they are the same magnitude, same direction. We just used polygon method here earlier, and we used parallelogram method here. So you should get the same answer. Okay? So you can explore this Fet Colorado software. It's for free. So yeah, and then you can check your answer. Okay, have a great day. See you later in our component method.